about Lesson 16, Analytical Separation. Before that, let me present to you our learning objectives and conceptual framework. Separations exploit differences in chemical properties or physical properties such as size, shape, mass, density, or chemical affinity between the constituent of a mixture. Now, what is the purpose of separation? Separation of substances is necessary to obtain pure substances for domestic purposes, industrial purposes, and research work. Several methods can be used to deal with interferences in analytical procedure, so separation isolates the analyte from potentially interfering constituents. However, a substance that affects an analytical signal or the background is called an interference or an interferent. Now, what do you mean by interferent? An interferent is a chemical species that causes a systematic error in analysis by enhancing the analytical signal or the background. Now, who discovered analytical chemistry? Isaac Maurits Kolthoff is widely regarded as the father of modern analytical chemistry. His research transformed the ways by which scientists separate, identify, and quantify chemical substances. The first instrumental analysis was flame-emissive spectrometry developed by Robert Bunsen and Gustav Kirchhoff, who discovered rubidium and calcium in 1860. Most of the major developments in analytical chemistry take place after 1900s.
The chemical methods and techniques of analytical separation. Distillation and its companion processes, isotropic and extractive distillation, are by far the most widely used separation processes for mixture that can be vaporized. Distillation is a process for isolating components from a mixture based on differences in boiling points. The second one is crystallization. It is used to achieve several functions such as purification, separation, concentration, solidification, and the production of crystal that can be used to determine molecular structure. The third one is the adsorption. It is a method of fractionating mixtures using microporous solids, or what we call the adsorbents, that have strong affinities for one or more of the components in the mixture, or what we call the adsorbates. The process is necessarily cyclic and alternating between absorption and desorption. The next one is the membrane processes. Separation processes involving membranes require two bulk phases that are physically separated by a third phase, which is the membrane. In all membrane processes, the feed is separated into two phases: the permeate, or the materials that go through the membrane, and the retentate, which is the portion of the feed retained by the membrane. The transportation of the materials between the permeate and the retentate phases is controlled by the membrane and the operating conditions. The next one is absorption and stripping. Absorption refers to the transfer of one or more components of a gas phase to a liquid phase, in which a gas phase is soluble. Stripping is exactly the reverse, because the transfer of a component from a liquid phase in which it is dissolved to a gas phase. And there are three types of absorption processes, and these are the separation based on physical solution, and separation based on reversible chemical reaction, and the last one is the separation based on irreversible chemical reaction. Absorption processes require the generation of extensive areas of the liquid surfaces in contact with gas phases. The last and final thing is the extraction. Liquid-to-liquid extraction is a separation technique involving two immiscible liquid phases. During liquid-to-liquid extraction, one of the two phases, the solvent phase, extracts the solutes from the other liquid phase. Solvent recovery and raffinated cleanup follow the separation.
The world around us is filled with naturally occurring mixture. Quite often, might want to separate this mixture to their components so that we collect useful or precious chemicals. In our earlier video, substances and mixture, we defined a mixture as two or more substances that have been physically and non-chemical combined. Mixtures may contain combinations of gases, liquids, and solids that can be separated through physical means. In other words, the separation of mixtures involves physical change. Physical change is a change in the physical properties of a substance that does not involve a change in its chemical compositions. This means that a physical change does not involve chemical bonds being formed or broken. Examples includes changing between the physical states of solid, liquid, and gas, dissolving into or precipitating out of solutions, and physical separating in the components of mixtures. We need to consider the physical properties of a mixture when selecting separation techniques. Physical properties include particles, size, density, melting and boiling points, solubility, magnetism, and electrostatic attraction in a mixture. Pure substances retain their distinct physical properties, and any differences in these physical properties can be used to separate mixtures. In this lesson, we will focus on separation techniques that rely on differences in particles, size, and density. Sometimes the major differences between two or more components in a mixture is particles, size, as mentioned on a pure substances and mixtures, is saving a separation technique, where particles are separated by size, substances with particles that are smaller than the holes in the sheave or pass through, while substances with a large particle will collect in the sheave. Remember our earlier video, pure substances and mixture. Blackbeard the pirate wanted to separate the heterogeneous mixture or gold coin and sand. If you recall, heterogeneous mixture is a mixture that has variable composition and properties in a composition. A heterogeneous mixture is a mixture that has uniform composition and properties. To separate the gold coin from the sand, Blackbeard used a sheave that has holes smaller than a gold coin, but larger than the sand particles. That way, the gold coin collect in the sheave while the sand fell to the ground. In some mixtures, the key difference between two or more pure substances is their density. Density is the mass of the substance per unit volume. We usually measure the density in kilogram per cubic meter or in grams per cubic centimeter. For example, water has a density of approximately 1 grams per cubic centimeter, while iron has density of 7.8 grams per cubic centimeter. But beware, the mass or weight of a substance is not the same its density. Density is the mass of a substance divided by the volume. If we consider a 1 kilogram chemistry textbook, a 1 kilogram of feather, they both have the same mass, 1 kilogram, but if you throw this in the ocean, after your final exams, the chemistry textbooks will sink when the feather will float. It is because the 1 kilogram of feather takes up a much larger volume.